Hello and welcome to another video. As some of you may know, I am the maintainer of flake8 and I recently released version 5.0 and in that release the performance improved by about 15 to 20%. So I wanted to walk you through some of the changes that led to that performance boost, and some of them are kind of surprising. Like, you wouldn't really think about them taking a bunch of time, but I was able to make a pretty significant improvement there. Anyway, let's jump into it. Okay, so in order to figure out what performance things changed, because there were nearly 100 commits that went into the, well, 100 merge commits, so even more, that went into the most recent release over a 9-month period, I set up a little profiling script to try and understand what the time was. And I was specifically profiling against pyupgrade and profiling in single process mode. This helped eliminate, as many noisy background effects as possible. I basically did a best of five and got some very basic performance metrics. When I actually went through and figured out the stuff to fix, I used the same performance tooling that I use for basically everything else. I did a video on that, so I will link that in the description. But I basically ran the script against every commit from last release until this release, and ended up with this little performance log, which kind of shows me each commit about how it performs. And so we can see kind of the big changes here. Like, here's one inflection point, there's another one here, another one here, and we can kind of track what changed in those. Overall, there's about 4 commits that I think are worth looking at, and we're going to look at each of those individually. Let's look at the first one. So this is, I guess, spoilers, this is the, oh my goodness, surprising. I never thought that this was going to take a lot of time. So in this one, I removed logging that was only hit in the extremely verbose case. So even though the log level was set very, very low, this log line here, where is it? Right here? Yes, this log line here, which only happened in the case where you did verbose 3 times. So it was 99.99% of the time completely hidden. This log line contributed to about 5% of the performance of flake8. And so removing this log.debug, essentially log.debug, although it's more like log.superdebug, that sped up flake8 a lot, even though it was not being displayed at all. So even just the function call overhead of this was significant. All right, let's take a look at the next one, which is probably this commit here. I believe this is more of the same. I found another debug log that was particularly expensive. Yeah, here's another one. Yeah, this log.debug also was taking a lot of time, even though it's a debug log, so it's not shown by default, but just calling this function alone was enough to make a pretty significant difference on the performance execution. And I believe, wait, didn't I say there was 4? Well, there's a few in here that are pretty minor performance that we won't talk about. We'll talk about this last one, though. This one is a pretty wild performance change here. And in this change, I basically, so the way flake8 works is you can plug in a whole bunch of linters to it. It discovers all of those entry points and then calls them with either the AST tree or a line of code or a series of tokens, or like there's a whole bunch of different ways that plugins can integrate into flake8, and flake8 can pass various information to them. And one of the built-in plugins is called pycodestyle, and pycodestyle provides something like 30 functions that do different linting things. And every time flake8 has to call one of those functions, it has to figure out, okay, what information does this plugin need, build up the dictionary of the keyword arguments for that plugin, and then call the function with those keyword arguments. And it turns out that building that dictionary, it's not super expensive on its own, but when you do that a bunch of times, it compounds pretty significantly. And so what I did instead was took the pycodestyle plugin, which is one of the built-in plugins that has a lot of functions, and I wrote some code generation so that instead of having, all of these functions being called, I just have two individual plugins, and those manually call the underlying function. So it doesn't have to build any of those keyword argument dictionaries. It just has to build this keyword argument dictionary a single time. And, and this alone speeds up flake8 by about 10%. Funny thing about this is flake8 is now faster at running pycodestyle than pycodestyle is at running itself. So this little optimization here, just the function call overhead and building those dictionaries, makes flake8 even faster than one of the plugins it uses. The sum of the parts is somehow faster than one of the parts, which I think is pretty funny. But yeah, basically I was able to pre-generate this plugin, and that made things go way, way faster. There's some related stuff down here about this. And then I made sure to write a test just so that this doesn't regress, to make sure that the plugin is up to date with things. There should also be one, well, probably lost in the noise of the refactor here. There was actually one performance improvement inside pycodestyle itself that showed up on some profiles, but not too terribly many. Authored by me, merged. Where was it? This one. Teeny tiny performance improvement by using short circuit evaluation instead of computing all of these ifs here. And this, I think, yeah, was about a 1% improvement in pycodestyle, which pycodestyle is only one part of flake8, so it doesn't necessarily contribute to the overall performance of stuff, but made a pretty significant difference in pycodestyle. But anyway, those are some of the performance improvements that were made as part of the flake8 5 release. Hopefully you found some tiny insights into this interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.